Hello and welcome. This is lecture number 9. It's going to be all about valence electrons. Go ahead and put the lecture number and today's date at the top of your notes. So what is an electron shell? So a really simple way to think about an atom is having a nucleus, which we'll just represent as a solid ball. We know that it's actually composed of protons and neutrons glued together, but we're not worried about that right now. The electron shell can be thought of almost like an orbital, like a planet orbiting a star. The shell is where the electrons can live. They just stay in orbit around the nucleus at specific distances. And the number of electrons that can fit into each of these shells is fixed. The innermost shell can fit 2 electrons. The next shell out can fit 8. And I think it's useful to just think of each additional shell as being able to fit 8 more electrons. The transition metals make this a little bit more messy, but this is a really simple way to think about it. It's just 2 for the innermost shell and then 8 more for each additional shell. All right, and another word for a shell is an orbital. And this right here is the nucleus. Now you might have heard of this term valence electron. What is a valence electron? It's an electron in the outermost shell. So let's draw another diagram of an atom. Here we've got our nucleus. We might have a shell. The first shell always has 2 in it. The next shell out can fit 8. So let's say that this is a big enough atom that it's got 8 in the next shell. But then it only has 3 more electrons. So they can't fit into any of these lower shells. So they only fit into this outermost shell. And here we can say that this atom has 3 valence electrons. So what's special about these valence electrons? Well, because they're the furthest out, they're the ones that are available, let's write this down, to form bonds. The electrons further in are shielded, so they can't really interact with other atoms, but the furthest ones out are available to form bonds and perform reactions. So let's write that this is shielded. So here's a useful diagram to add to your notes. You don't have to draw out a perfect periodic table, but you can sketch one. I think it's really important to note that all of the elements in group 1 have 1 valence electron. Even though, lithium has 3 electrons, a neutral sodium has 11, because of the way that they fill in those orbitals, they both just have 1 that's in the outermost orbital available to bond. Now 1 is a kind of dangerous number because our atom would like to lose that 1 because there's nothing to really support it out in that furthest orbital. So that helps to explain why elements in this first group are so reactive, is because they all have the same number of valence electrons. And that's why the periodic table is set up in this way, is to have our groups have similar properties, and that's caused by the valence electrons. Now, transition metals are pretty strange. Because of the way they add electrons, It's not quite as obvious how many valence electrons they have. So for this whole region in here, we say it's anywhere between 3 and 12 that are true valence electrons available to do bonding. But we'll talk more about how the electrons are filled in for these ones here. The pattern then becomes really simple once we get back into the main group. That group 13 has 3 electrons, group 14 has 4 valence electrons, and so on. All you have to do is just chop off the 1 from the group number, and you know how many valence electrons it has, all the way up to the noble gases, which have 8 valence electrons, forming a perfect octet. That's why noble gases are so happy and they don't really want to do any bonding, is those 8 electrons, they kind of support each other, and none of them are vulnerable to be picked off for bonds or for reactions. All right, so that's all I really want to say about valence electrons for this lecture video. For the test, all I want you to know is how many valence electrons are in each of the elements of the main group. As a reminder, the main group are groups 1 and 2, and then 13 through 18. So don't worry about the transition metals or the intertransition metals. I just want to know for our main group, can you tell me how many valence electrons there are for each of those atoms? All right, and it's very simple. It's just the group number, except for with 13 through 18, you get rid of the 1. That's all you have to do. All right, so I'll embed a few more questions here, but that's that for this lecture video. Have